Hello everyone, and welcome to today's presentation. I'm excited to share some insights on a very interesting topic. The title of our presentation is, Why is that a mucolyte does not dissolve the mucus lining the stomach, but only acts on phlegm in the throat? We will explore how mucolytic agents work and why their action is specific to certain types of mucus. Over the next few slides, we'll look into the differences between respiratory mucus and gastric mucus, and understand why these medications behave the way they do. Let's get started. Let's take a closer look at the differences in mucus composition. In the stomach, the mucus is really specialized. It contains high levels of mucin glycoproteins, bicarbonate, and protective lipids. This combination forms a thick, gel-like barrier that plays a crucial role in shielding the stomach lining from the harsh acid environment. This mucus is designed to be sturdy and resilient. In contrast, respiratory mucus, often called phlegm, is much less viscous. Its main components are mucins and water. The primary purpose of respiratory mucus is to trap pathogens, like bacteria or viruses, and particulates such as dust or pollution. Then, through coughing or sneezing, it helps remove these unwanted particles from our airways. So, while both types of mucus serve protective roles, their composition and physical properties are tailored to their specific environments. This highlights how our bodies adapt these mucus barriers to effectively defend different parts of our system. Let's take a closer look at how mucolytics, like acetylcysteine, actually work. They target the mucins in respiratory mucus by breaking the disulfide bonds that hold the mucin molecules together. This process reduces the viscosity of the mucus, making it much easier to expel through coughing or other mechanisms. It's important to note that these agents are quite selective. They don't affect the structure or the composition of gastric mucus, which is inherently more robust and chemically different from respiratory mucus. This selectivity is intentional. Mucolytics are designed to act mainly in the respiratory tissues, where they are needed most, while sparing the gastric mucosa. This way, they can effectively help clear mucus from the lungs without causing unnecessary disruption elsewhere. Understanding this mechanism helps us appreciate how targeted and safe mucolytics can be when used appropriately in respiratory conditions. The gastric mucus layer plays a crucial role in protecting the stomach's epithelial lining from several potential threats. Unlike the mucus in our airways, which primarily helps clear debris and foreign particles, the mucus in the stomach has a more defensive function. It acts as a vital barrier against digestive acids and enzymes that are necessary for breaking down food, but can also be harmful to the stomach tissue itself. Additionally, this mucus layer helps shield the stomach from mechanical injuries that could result from the physical process of digestion. So, in essence, this layer is essential for maintaining the integrity of the stomach lining and preventing damage, which is a key part of the overall protective mechanisms our body has evolved. When ambroxol hydrochloride syrup is taken, it primarily works as a mucolytic in the respiratory tract. This means it helps to thin and loosen the phlegm, making it easier to cough up and clear from the airways. This action is really important because it helps patients breathe more comfortably and speeds up recovery. It's also important to note that ambroxol does not chemically interact with or dissolve the protective gastric mucus lining in the stomach. So, while it acts effectively in the lungs to break down mucus, it doesn't harm the stomach's natural mucus barrier. This distinction highlights how targeted and safe the medication is, focusing on respiratory health without affecting other protective mechanisms in the body. Understanding this helps us appreciate the role ambroxol plays in managing respiratory conditions effectively and safely.